All right, 8.3 polynomial divisions. We're going to get into today looking a little deeper at what polynomial division can do with us. We're going to stick specifically to synthetic because that way it's going to throw things out perfectly for us, make life a little bit easier. We could use long division, but that's a little more work, and we don't want to have to do that if we don't have to. We want to take that easier route. Okay, so let's get into our definitions here. And so our first definition is the remainder theorem. Okay, so the remainder theorem states if f of x equals x minus c times q of x plus r. Okay. Now, all this is kind of our factored form of our function. If we were to factor off a piece, we would get the factor. We would get the quotient, that's why it's q of x, and then the remainder of whatever that factor was. Okay, now it's not, since we have a remainder, it means it didn't factor evenly, but that's okay for those pieces. All right. So if we're able to get it into this form, then f of c equals r. Okay. Now, what's happening there is if we take this c value and plug it back in right here, c minus c is 0. 0 times anything is 0 plus r gives me the r. So the mathematics works there on that. So that does allow us to look and see, can we divide, broke it down, and so that means what we were doing with those pieces is the remainder for that. Okay. And so we're going to use that to our advantage here momentarily. Our second one is the factor theorem. Okay, which states if f of c equals 0, then x minus c is a factor of f of x. Make sure I write that correctly. Okay. So if we plug some value in our function and we get 0, then x minus that is a factor. And if we were to go back and think about factoring forms, we factored stuff, we got x plus or minus a number, and we set it equals 0. And solved, and we got x equals that number. Essentially, we were doing that. We're just going the opposite direction from it. We used the factor to find c. Here we're using c to find a factor for those. And so we want to be able to do that as well. Okay. All right, so let's look at our examples and see what's happening there. So our first one is to determine if the following is a factor of f of x equals x to the 4th minus 6x to the 3rd plus x squared plus 24x minus 20. Barely got it in there on the board. Okay. And so for our first one here, we want to see is x plus 1 a factor of this. Okay. Now, for it to be a factor, that means that once we work this out, it should divide evenly, right? For those. Now, another way to look at it is to kind of use the opposite of this piece here for those. If we think of x minus c as a factor, that means f of c should equal 0. Okay, so we got to think through this. This is plus, so we're actually going to look at the negative of this thing. Okay, but we don't want to go through actually just plugging it in and seeing what's happening there. We're going to use synthetic division. Okay, and so that's what we're going to do here for this. All right, so to know if this is a factor, we'll always do the opposite on the outside here when we have x plus or minus. for those. So if we have our x with it, we do the opposite. We're going to see later on they're just going to give us a number. In those cases, we hold true with it. But here we do not. Okay. Now I'm going to do my synthetic division here. We have 4, 3, 2, 1, 0. We have all of our x's with their powers. So we take those coefficients that we learned before. And so here that's 1, -6, 1, 24, -20. Okay. All right, so using our synthetic division, we bring down our 1, our first one. -1 times 1 is -1. We put those together. So -6 plus -1 is -7. -1 times -7 is a +7. 1 plus 7 is 8. -1 times 8 is a -8. 24 plus a -8 was that -16. Nope, +16, sorry. Getting ahead of myself. -1 times 16 is a -16, so we get a -36. Now we need that remainder to be 0. Okay, our last one is always our remainder here. So we look at this last piece, that's my remainder. That does not equal 0. So no, this is not a factor of that equation. Okay, so that's what we're looking for there, to be able to tell if something's a factor or not. All right. All right, let's erase here. Okay, that's number 2. X minus 2 is going to be what we're curious. We're using the same equation. So we'll note x minus 2 is a factor. All right, so do the same thing there. I'm going to do it underneath this time. So we do the opposite. So +2, and 1, -6, 1, 24, and -20. So we bring down that 1. 2 times 1 is 2. -6 plus 2 is a -4. 2 times -4 is a -8. So 1 times -8 is, or plus -8 is a -7. 2 times -7 is a -14. 24 plus a -14 is 10. 2 times 10 is 20. -20 plus 20 is 0. That does equal 0. So yes, this is a factor. Okay, so you can see there when we get to that remainder, if it is a 0, then we're good. Okay. Now, yes, technically we could take -1 here, plug it in, we would see we wouldn't get 0. If we took 2 and plugged it in to our original here, you would see that we do get 0. So those are other options, but I want to see synthetic division. We also want to do it that way to practice. We're going to do synthetic division for the rest of our problems here. So that's why we want to do that, to make sure we know how to do that anyway. But also it makes it easier. You notice I didn't need to pull out a calculator for any of that. Very simple to do. Whereas I start giving you bigger numbers with this x to the 4th, it's going to get ugly really fast. And so by using these coefficients, it works out a lot better. Okay. And so my expectation is for you to use synthetic division. All right, our next example. I use synthetic division to find the quotient and remainder. So this is just simply divide on this one, okay? And so we want to find those pieces. I guess I do need my numbers here. So 2x to the 4th plus 7x to the 3rd plus x minus 12 divided by x plus 3. Okay. All right, so we do our synthetic division. Again, we do opposite because we have that x with it. So -3. And then here we have 4, 3, but we're missing x squared. So we're going to need to put a 0 in there. So here, this is a 2, 7, 0, 1, and -12. Okay, so 2, 7, there's no x squared. So we put that 0 in, 1, and then -12. Is where I got all those numbers from. We have to have them all represented. All right, so our first one comes down. So we get 2. -3 times 2 is -6. So it's going to give us 1. -3 times 1 is -3. So -3. -3 and -3 is going to give me 9. So we're going to get 10 there. -3 times 10 is a -30. So we get -42. Okay. Now our last one is always the remainder. So that's going to be the easy part for us here. But here we got to remember all those pieces. And actually a quick way, we started at x to the 4th. We divided by 1. So we're subtracting 1. So that's going to be 2 x to the 3rd plus 1 x squared minus 3x plus 10. This here is going to be my q of x, or my quotient. And then my r of x is going to be -42. And so that's my remainder. Okay. For those. So much of what we've done previously in other units. Okay. All right. Use synthetic division. To find the function values for f of x equals x to the 3rd minus 6x squared plus 11x minus 6. And we'll start here, number 1. We're going to do f of 1. Okay. Now, yes, again, we could just plug in 1, but we want to use synthetic division to show how to do this. All right. So let's look at that. All right. So since we're doing synthetic division here, we're going to use what's inside. Now, this time we're going to stay true. Notice there's no x with that. It's just f of the numbers. We're taking the number directly, which is 1. Now we do our synthetic division. So we have all our powers. So 1, -6, 11, and -6. The reason that looks funny, let me make sure I wrote it down correct. All right. Yes, I did. Okay, so we do our synthetic division. We bring down our 1. 1 times 1 is 1. We add, we get -5. 1 times -5 is -5. We add here and we get 6. And so 1 times 6 is 6. If I've done all my math correctly there, I get 0. Okay. So what does that mean? That means that f of 1 equals 0. It's always going to be our remainder for that one. Okay. So that's what we're going to be looking for there, doing that remainder and finding that piece. Go back to our remainder theorem. So what is f of -2? Okay. So doing the same exact process here using our synthetic division for those. And so we have our -2, 1, -6, 11, and -6 because I'm using the same exact function here. So we bring down our 1, we get -2 times 1 is -2. We add and get -8. Multiply here to get 16. We add those to get 27. And negative 2 times 27 is a negative 54. So we put those together to get negative 60. Okay? So that means that f of negative 2 equals negative 60. Right. All right, what's next? All right, now we want to determine if things are zeros. So determine if numbers are zeros of f of x equals x to the third minus 4x squared is 4x minus 16. And number one, we're going to look at the number I. Okay, number I here for those. Now, 0 is part of a factor. We looked at that a while ago. So if it gives us a remainder of 0, then we know that it's going to work. Okay, that's going to be how we use this. We're going to still do synthetic division. And yes, you can try to plug that in to simplify, but that may get a little confusing with all of the squares and the i's and all of those things. And even when we write this out, it's going to be a little different, but we're going to see how to apply it here. Okay. All right, now because there's no x on this, we're going to leave it as I. We don't change that over. So up here we get 1, negative 4, positive 4, and negative 16. Okay. Let's draw our piece across there. So we bring down our 1. So I times 1 is I. Now we got to remember we're adding here, we have to do like terms. So this one is negative 4 plus I, which is just negative 4 plus I. Okay. And we're going to do I times negative 4. That's negative 4I. I times I is I squared, which is negative 1. So we've got to be careful about those things and make sure we're doing that math correctly. Remember to change those powers over. All right, so now we add 4 plus negative 1 is a 3, and then minus 4I. Well, I times 3 is 3I, positive 3I. I times negative 4I, well, that's negative 4I squared, which is going to make that a positive 4. And then we add these, we're going to get negative 12 plus 3I. Okay. Now that is our remainder. That does not equal 0. So no, this is not a 0 of that function. And I do expect to see all of that work all the way to the end. Even if you think early on that it's not going to work, I do need to see it go all the way out there, just like I have on the board. That is my expectation. So number 2, negative 2I. Okay, so let's see if that one works. All right, I'm going to do it a little bit lower here. So negative 2I. We have the same numbers, 1, negative 4, positive 4, negative 16. And I do recommend maybe giving a little extra space between these numbers because we see that we're having to add the i's and all of that stuff. So maybe a good idea to do that. All right, let's bring down our 1. Negative 2I times 1 is negative 2I. These we cannot combine, so we get negative 4 minus 2I. Here we need to multiply, so negative 2I times negative 4 is a positive 8I. Negative 2I times negative 2I is a positive 4I squared, which makes negative 4. Now these 4's kill each other, leaving me with 8I. Negative 2I times 8I is a negative 16I squared, which makes that a positive 16. So we do get 0. That equals 0. So yes, This one is a 0 of the function. Okay. So we've got to think through all of those pieces. You're going to get I-squareds. You need to change those over to -1, which is going to change the sign of the number in front of it each time. So you'll have that to your advantage. Okay. All right, finally, let's divide here. So divide 1. So x to the third plus 3ix squared minus 4ix minus 2 divided by x plus I. Just a whole lot of i's going on with this, and that's okay. Now we're still going to use synthetic division here for this, but because we have the x involved right there, we do the opposite. So this is plus I, so we need to do minus I. Grab the wrong marker. So minus I, and then here we have 1, 3i, -4i, and -2. All right. Okay, let's bring down that 1. So -i times 1 is -i. 3i plus a -i is 2i. -i times 2i, that's -2i squared, which makes that +2. We can't put those together, so we get 2 minus 4i. -i times 2 is a -2i. -i times -4i is a +4i squared, which makes -4. And then we put those together, we get -6 minus 2i. All right, so that lets us know that our quotient Q of x here, well, we started with x to the third, so this is x squared plus 2ix plus 2 minus 4i with a remainder of -6 minus 2i. And it may come in different forms, but you're going to be able to recognize where that remainder is and all of those things. Okay. And this is our answer. Okay. But you can see a lot of different things come from that division. We're doing it on purpose to be able to work through that synthetic division. It usually makes things a little bit easier than just trying to plug and chug, remembering when to do it. Pretty much this section, everything is synthetic division. The big key is, do I change the sign or not? If I have the x with it, I do the opposite. If I do not, I keep it as it is. So remember those details.